Okay, we are finishing up today with functions and inverses. We are still working through old papers, how it gets asked. This particular one doesn't get asked that much, but when it is asked, you must identify it. So they've given you a sketch. It almost looks like it could be a log graph. It maybe went through there and went up and now it's restricted. But when you read and you see fx equal to something with a root, that root should give you the indication that it's the inverse of a parabola. You should know that. Okay. Now, if you see that and you go back there, it makes sense. But it's not the complete inverse of a parabola, because remember, the inverse of a parabola, if it's not restricted, it's not a what? A function. So it was restricted. That leg there has not been sketched. It's been erased. It's been limited. That y can only be less than 0. If that is the case, do we call f a function? Yes. Do we call this f a function? Yes. Yes, when one of the legs has been restricted. And then why is it a function? Because every x is only one y. That's it. And if it isn't a function, you say it's not a function because every x is not only one y. The exact wording, please, guys. Alright. It will be asked somewhere this year. So, for which values of x, now the question comes, for which values of x in this graph, f, will f, what's this? F y. Will y be bigger or equal to negative 9? Where's that on the graph? Where's there? That point is 9. They won't give me the point for nothing. They won't use -5 now somewhere here. If that's the question that was asked, they can later on and then you'll go and work it out. But if that's -9, I'm talking about this point here. So for which values of x will y be bigger than -9? Which is bigger than -9? Up. That's bigger than -9. Because that y is -9, -8, negative whatever, bigger. Those y's are smaller than -9. So you're looking at this piece here. So for which x does that happen? For x? Less than or equal. Is that it? Because the graph stops. So you can also have to stop at 0. X is equal to 0. So it must be bigger than 0. Can it be 0 though as well? Yes. Yeah, no problem with the 0. If it's included and bigger, then that should be included as well. For 2 marks. Can you see where the 2 marks go? And then lots of people might have missed this. Okay, that was just looking at your graph. Second one asks you what you were waiting for. Find me the inverse. So obviously the inverse of this thing is going to have to be a parabola. You must expect it. How do you get the inverse? First mark. So you're going to write x is equal to negative square root 27. And then we never leave it that way. The question also said, find the equation in the form y is equal to. So how will you get that as y is equal to? You can swap them around, that's fine. You can divide the whole thing by a negative, that's fine. You want the y on the left hand side, so maybe let's do that. So you've got root 27y equal to negative x. Or if you divided the whole thing by a negative, but you could have from the start said, I need that root away. How am I going to get it away? By squaring it. So earlier or later, you're going to have to square. And what do you square? The whole side. The whole side. Not bit by bit, the whole side. If you square this whole side, what do you get? 27y is equal to x squared. Because remember this, the negative falls away because the negative squared is a positive. Now I only have to write y is equal to over 27. I have no problem with that. Maybe it's better if you write 1 over 27 x squared. So you can better see the general solution or the general form of a parabola. A x squared plus bx plus c, and b and c are both 0. Why is the b 0? B is always 0 in a parabola when it's symmetrical around the axis, and it's going to happen. C is 0 because the C is the y-intercept, which you can see is 0. Everything falls into place. And then I just like to write here f minus 1 for the y value as well. That's fine. If you had left it y is equal to x squared over 27, that's fine. But please remember, when you do this whole swapping thing, it's everything. Also the restriction. So if that restriction said that x must be bigger or equal to 0, then you've got to say here that
y must be bigger or equal to 0.
Oh, excellent, because most probably that was with one of the marks as well. Except for swapping and writing it in correct form, because that could be 3 marks, and then there's your 4th mark. Okay, now we've got to sketch it. Could we have sketched this without doing anything else? None of this done. Could we have sketched the inverse? Yeah?
Yeah.
Because how do you sketch an inverse? Swap everything. So what have you got?
Y
P,
is
yeah.
3. Y is.
So y equals
So, and new y.
The new point
p.
is minus 9.
And 3.
Where is that? Minus 9, 3. Now also keep in mind, because you are so nice and clever, that you want to sketch this symmetrical about the line of symmetry of the inverse and its function. So when you sketch it, try and make it look symmetrical. So where's this point on this side if I want to make it symmetrical? So remember, it's not a sketch graph, so it's not accurate. But if I want to go sketch it, I'll make it like maybe over there. Negative 9 and 3. So that when I sketch it, kind of plus minus, almost it looks like it's mirror imaging. Are you with me? And what about this one? Well, that was the given rule. When you swap 0, 0, it's still going to be 0. 0, it has to go through there as well. And that was with 3 marks. So what's the 3 marks for, do you think? For that point? And that point, and exactly right. The shape. They never ask you to show the line of symmetry, but it's a good idea to always do it. And if they ask you for that equation, what would they ask? Find me the equation of the line of symmetry for f and f minus 1, or the line of reflection of the two of each other. Alright, and that was with 3 marks. Then, lastly, the question says, please describe the transformation before you read anything else. What is a description of a transformation? The only ones that you have. It's either
right,
goes right with 3 units, or up with 2 units, or down, or left or right. And then also,
Reflection.
yes, reflection. What reflections do you have?
Reflection about the axis.
About the x-axis. How does that happen? When you
Change the y.
change the y into a negative. If it was negative, any time it with a negative, you're going to get positive. So if the y is timed with a negative, you get symmetrical around the x-axis, reflection around the x-axis. If it's the y-axis, how do you get the reflection? Change the x into a negative x, or times the x with a negative. And now you've got a third one, reflection about the line y equal to x. So are you with me? Those are your transformations. Okay. Now they say, describe for me what happened to f to get to g, which is a new one. G wasn't given. I'm getting to g, but tell me what happened from there to there. That a? Are you going to say something about a? No, only those words that we said now. It's moved up by so many, left by so many, or it's a reflection around the x or y axis, or around that y equal to x. What is it? It's a reflection. What happened? The
X value changed.
the y.
the y value changed.
Right.
Y was negative. Now y is positive. So if y was negative and now positive, it's a reflection around the around about the x-axis. That's it. It's right or it's wrong. But what was it about? The negative became a positive. It was y that was negative that's now a positive. So if y is multiplied by a negative, it's about the x-axis. Are you with me here? That's it. Don't tell me there's a negative that's now gone, or you timed the a with something. That's not explaining what the transformation was. Okay. Our very last one, before we carry on to our new topic, is a log graph. It's been given to you. Normally, generally, mostly, they start off with exponential graph and they want you to go to log. But it does happen that you get the log graph and you've got to go to exponents. You're looking for it. Somewhere in the sum you're looking for the inverses. It has to be there. Right. So if the log graph is y equal to log 4x, the first question was what is k? Where is k?
Okay.
That point that they gave you, but the moment you get a point on whatever graph, what do you do with it? Substitute it. So if you substitute that point, we're going to have, in the place of y, 2. And in the place of x,
K.
right? So we have, what must we do? Take it into exponential form, which is going to be 4 to the 2 is k, and k is equal to 16. What does that tell me about the sketch? That point there was 16 and 2. That doesn't change the equation. The equation was given. There was no variable there. The equation was given. 2 marks because of the substitution and the answer, because you needed the exponential form there, your definition going from one to the other, logs to exponential or exponential to logs. Next question says, find the values of x. That's always the question, eh? Find the values of x for which something happens. What are they asking me? Because everybody can read -1 smaller than fx smaller than 2, but what does that mean? Where is the y value between -1 and 2? Where is the y value? 2, I can see. Are you with me? 2, I can see, that's there. So for which x value will it be less than 2? Oh, yeah, the y value less than 2. For x, smaller than 16. That's why you needed the 16. But that doesn't go on forever. They're asking me at -1, but I don't have that. How can I get it? Because actually they're saying, if I know that the y value is -1, I need the x. So where would that be approximately? Y value here should be somewhere with -1, but I'm needing the x. So how do I find that? I've just got my equation. So if my y value is -1 in my equation, then -1 is equal to log 4 of x. I'm trying to find if y is equal to -1. What will be the x? So how would I go on about this? Again, the log definition, back to exponential. So we'll write 4 to the power of -1 is x, meaning that x is a quarter. What have I just found? That point there is the quarter and -1. Why did I want that? Because I wanted to know when y is between 2 and -1. Where does that happen on my graph? Where y is between 2 and -1. For which x's does that happen? X between a quarter and 16. You see it? So x between a quarter and 16, and that's the way you were taught to write it, between. And if that is included, then that should be included. They could have maybe said, let's exclude that one, then this one would have been excluded as well. Or if there's asymptotes, just have a look on that. Does it make sense now?
Yes, ma'am.
But it's reading, and you didn't have the corresponding X, you had to first go and find it, and then they say, therefore my answer goes between the two. Okay, eventually it's the one I've been looking for. For inverses, we swap X and Y, so what's going to happen to my equation? X equals, and the Y. Could you have made this into exponent form and then swap the X and Y's? Okay, now I've swapped them and now I'm going to go to exponent form. That's going to be Y is equal to 4 to the X. I'm just putting the Y in the front instead of saying 4 to the X equals Y, because I like it in that form, and they asked me for Y equal to. And you could even nicely finish it up and say that's equal to Fx, but that's perfect. Swap them, write it in the correct form. Alright, now the last question, and then it gets a little bit harder because you're just going to write the answer and you're not going to know where the answer comes from if I just tell you what the answer is. You've got to read what's going on here. Where is X? Now what is X? What X? That's your X-axis. So this is all X. Okay? The X must be multiplied with the inverse. So do I have the inverse?
Yes.
Not on my sketch. Can I quickly get it? So it makes more sense. So if I quickly want to go get it, what's the x-intercept, you think? In general, if there's not much going on in front, it's usually 1. How will you find it out? Substitute your y value with a 0. So if your y value is a 0, 4 to the 0 is going to be 1. In general, log graphs cut at 1, so exponential graphs also cut at 1. If they don't have much of a b times a to the x, something happening there, if it's just log ax, then it's always at 1. So if I know that, then this should be the y-intercept here. We don't even have to use both of them, let's just use 16 and 2. So 2 and 16 should be somewhere over there, you agree?
Yes.
And what's the graph going to look like? Oh, sorry, 16 and 2 constant there because on the positive side, I'm sorry. So then, and also remember, we want to sketch it symmetrical around the line y equal to x. So it's going to be somewhere like this. Coming closer to the x-axis, coming closer to the y-axis. Are you with me here?
Yes.
No marks given for this, I want to show you. So if the x's have to be timed with the inverse, what of the inverse? Y of the inverse. And the answer's got to be? No, that's not what I want to hear. Negative. There's something that you were taught in grade 10. If x, two things are timed and the answer's got to be negative. What must happen on the graphs? One at the top and one at the bottom. Why? Because to get to negative, it's got to be one at the top and one at the bottom. So this is what's happening here. One at the top, one at the top. What's going on here? So the one must be positive and the one must be negative. Makes more sense to write it that way here. But let's have a look. Where is x positive and negative? What x? Just x. All these x's are negative. All these x's are positive. If they are negative and positive, the other one's going to be the other way around. But if you look at the inverse, where's the y value, positive or negative? Look at the inverse. It's always positive. The y value in this complete thing up to infinity and coming closer, closer, closer to the asymptote will stay positive. The whole thing, the y is. So if it's got to be one positive, one negative, then this x has got to be negative. If that's definitely positive, then this has got to be negative. So what do I write? X. Well, that x is negative. That's my answer. So all the time here, the x's is negative, the y is positive, and multiplied they give me a negative. Think about it, chew on it. That is it. story time is over for functions.